So today we have an interesting geometrical problem. We take a semicircle. Now we inscribe a right angle triangle A, B, C inside it. Now we draw a perpendicular BM to the diameter of this semicircle. Now we draw a red circle such that it is tangent to the perpendicular BM, the circumference and the diameter of the semicircle. Now similarly we draw a blue circle and it is also tangent to the perpendicular BM and the circumference and diameter of the semicircle. Now we draw a yellow circle and this is tangent to all the three sides of the right angle triangle A, B, C. Now let the area of the red circle equals to X, area of the blue circle equals to Y and area of the yellow circle equals to Z. So now the question over here is to find a relation between X, Y and Z. So this is Anmol Mishra and now let us see the solution. How can we solve this problem? So first of all, I will take the radius of this red circle equals to A, radius of this blue circle equals to B and radius of this yellow circle as equals to C. Now as we have taken the radius of these three circles as variable, let us equate this thing to their area. So we know the formula for area, that is pi radius square. Therefore, area of the red circle, that is X, would be equals to pi A square. Similarly, the area of the blue circle, that is Y, would be equals to pi times B square, and similarly the area of the yellow circle, that is equals to Z, would be equals to pi times C square. So here we have got the value of X, Y and Z in terms of A, B and C respectively. Now to move further in the solution, I will simply take out three diagrams out of this main diagram. So here you can see all the three diagrams, and if you note, one thing is common between them. All of these three diagrams concentrate on one circle each. The first diagram concentrates on the red, the second one on the blue and the third one on the yellow circle. And separating these circles like this way will help us a lot. Let us see. We'll mark all the same things. This is the point A, the point B, the point C and this is the point M. And radius of this circle was taken as a variable A. This is the 90 degree and that is the other 90 degree. Now I will simply use a geometrical theorem about which I discussed in a video. So the theorem was like this way. If there is a semicircle, inside this semicircle if you draw a perpendicular, on one side of the perpendicular if you draw the triangle and on the other side you draw a circle such that it is tangent to the semicircle, the diameter and this perpendicular line, then there is a beautiful relation between the radius of this circle and the bottom base of this triangle with the hypotenuse. So if the radius of this circle has been taken as X, the bottom base of this triangle has been taken as N and the hypotenuse has been taken as M. Bottom base means from here to there. So there is a relation that the radius of this circle would be equals to M minus N, as simple as that. And if you want to see the proof of this particular theorem, the link is in the description. Okay, so we will utilize the same thing over here because we can see the same arrangement is there. A perpendicular line, on one side we have the triangle and on the other side we have a circle, tangent to the semicircle, tangent to the diameter, tangent to the perpendicular. Hence we can use this theorem. So radius of this circle has already been taken as A. Now I will take the base of this triangle as a variable D and hypotenuse as a variable E. So as per the theorem that we just saw, the value of A would be equals to E minus D. Okay. Now the same theorem we will utilize it in the second one also. Look carefully. First of all, let me mark all the required things. Now here also we can utilize the same theorem. A perpendicular is there. On one side we have the triangle and on the other side we have a circle such that it is tangent to the semicircle, tangent to the diameter, tangent to the perpendicular. So we can use the same theorem over here also. So already the radius of this blue circle was taken as B. Now this time let the distance of AM equals to F and the distance of AB equals to G. So as per the theorem, the value of B would now turn out to be G minus F. Okay. Now let us see the third one. So here also I will mark the same thing, the point A, the point B and the point C. Okay. Now the radius of this circle was taken as C. These 3 points are the tangent points, so I will directly draw radius to that points, and as the points are tangent point, the angle over there would be 90 degree. Okay. Now recall that we have taken the radius of this circle as a variable C. Okay. and the angle B is 90 degree because it is inscribed inside a semicircle. Now look in this particular quadrilateral. First of all, this fourth angle is also 90 degree by angle sum property. Now we have a quadrilateral, all the four angles are 90 degree and the adjacent sides are equal, hence it is a square. So this much distance would also be equals to C, and this much distance would also be equals to C. Now the complete distance is equals to AB, some part is equals to C, therefore the distance from here to here would be AB minus C. Similarly, the distance from here to here would be equals to BC minus C. Okay, now look carefully that from the point A, we have two tangents to this circle, hence both of these tangents would have the same length. The distance of one of the tangent is AB minus C, therefore the length of other tangent would also be AB minus C. Similarly, from the point C, we have two tangent. One of the tangent is already having a length BC minus C, therefore the length of other would also be equals to BC minus C. Now the complete length of this thing is equals to AC, and that has now become AB minus C plus BC minus C. And if we will simplify this thing in order to get the value of C, we will get that C is equals to AB plus BC minus AC divided by 2. So here you can see that we have got the radius of this yellow circle in terms of side length of this right angle triangle. We have got the third relation also, and it is also a relation between the radius and the side length of this right angle triangle. Now it is the time to assemble it. So look carefully in the first diagram. The variable D is equals to MC, and from the second diagram take F. So the distance F is equals to AM. And if I will simply add these two things, I will get that AM plus MC is equal to E plus F. Okay. Now as per the diagram, the value of AM plus MC is going to be the complete length AC. So here we have the value of AC, that is D plus F. Okay. And now from this second diagram, the direct value of AB is going to be equals to G, and from the first diagram, the direct value of BC we have taken as variable E. Okay, so now here we can see that we have got the value of AC, AB and BC in terms of D, E, F, G. So we can assemble this thing over there. We will simply replace AB, BC and AC with these values. So we will get the radius C equals to, now instead of AB we have G plus BC, so instead of BC we will put E minus AC, so instead of AC we have D plus F, therefore minus D plus F. And now if we will open the brackets, we will get it as negative D negative F, and all of this thing divided by 2. Now we will just assemble this thing. We will take G with F and E with D. So I can rewrite this thing as G minus F plus E minus D. Okay. Now look carefully over here. The first bracket is G minus F, and the value of G minus F is equals to B. Similarly, the second bracket is E minus D, and from this first equation we have the value of E minus D equals to A. So we can replace that thing over here. So we will finally get the value of C equals to A plus B upon 2. So here you can see that we have got a relation between the radius of these three circles, that the radius of the yellow circle equals to radius of the red circle plus radius of the blue circle upon 2. Now the original question was to get a relation between areas of these three circles. No worries, we have got a relation between the radius, and remember these three equations that we have got in the beginning. Using these two things we will get the answer also. So previously we have seen these three equations, that was a relation between the area and the radius. So simplifying this thing further, we can get the value of A as square root of x upon pi, the value of B equals to square root of y upon pi, and the value of C equals to square root of z upon pi. Okay, now the relation that we just got, that C equals to A plus B upon 2. In this relation we will replace C, A and B with these values. So doing so will give me square root of z upon pi equals to square root of x upon pi plus square root of y upon pi divided by 2. So now we can see that square root of pi got cancelled out simply. So we will get square root of z equals to square root of x plus square root of y divided by 2, and that's the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, do comment below, and if it's hard to comment, you can email me or else you can send it to me on my Instagram. The link is in the description.